So let's dive into that. So build server. In general, the concept of a build server is that, let's just say the number one definition here is that it runs things. And that's really the simplest possible way to think about it, is that it's an execution environment that you can put somewhere and it will run things for you. So it automates things. And in particular, what I think is really interesting about this is that there are many different options now. First, let me start with what I've known for a decade or more, is the open source build servers. And in terms of open source, one of the key options has been a tool called Jenkins. And Alfredo and I have actually done a lot of work on doing material around Jenkins. But the reason why people have used Jenkins for so long is that it's a pretty good product. It's actually very configurable and it's very powerful. And so many companies that I've worked at, I've used it for mobile. I've had, giant mobile farms of machines attached to an OS 10 build server that made sure that our iOS devices worked. Or I've also had the same Jenkins master server, go talk to other nodes that would go through and, let's say, do Linux testing, do, Windows testing. So it's a really flexible tool, and it's a very powerful tool. Now, the downside of it, which I've also experienced, is that it's a server. And the downside of a server is that eventually the server goes down. And this is really a problem for many companies, is that they may not have the expertise to really maintain a very complex Jenkins server, right? So you have, let's say, the master node here, and then you have, other child nodes here that are doing all kinds of work. And in fact, the master can get busy. There's all kinds of problems that occur in this architecture. They're definitely solvable, but it is a very complex solution. So that's opened the door for these third-party SaaS servers. And in particular, the third-party SaaS servers, some of the main players in that space right now would include CircleCI, which I've done a lot of work with, and GitHub Actions are two of probably the biggest ones right now in the third-party space. And so then it's worth talking about, well, what is it that you would do with these third-party build servers, and what problem do they solve? Well, in terms of the problem, one thing that I have the skill to set up extremely complex Jenkins infrastructures, and I've done it many times in my life, but I'm also efficient, and a lot of times it's like, well, do I really need Jenkins? Because I could lint my code, test my code by using a SaaS build server, and it just simplifies things. So the advantages of these are, if your primary purpose is code quality, let's say primary purpose is quality of your code, this is a really compelling offering because of the fact that you don't have to maintain this physical data center or this physical server, and it's also a really efficient process, right? It's efficient to build things out, and typically these will have a YAML file, right? So they'll go through and have some kind of a YAML file that you can configure, and a lot of times I would even make the case that even if you were using something like Jenkins, maybe also you could consider using something like GitHub Actions. And the other reason for this is that kind of hidden inside of this is this idea of source control hosting. And let me also kind of get into that as well, which is that this is somewhat of a hidden dependency that is often not thought about in testing, but where are you actually hosting your source control? And in the case of GitHub in particular, one of the things that's interesting about GitHub is that it does things other than just hosting your source control. So let's just take GitHub real quick and talk about some of the things that it does. So we know that GitHub will do things like we can do a build server, but it also does, ticket system. It also has a security scanning feature of it. It also has ability to do web hosting. So there's a whole bunch of, and I won't go into all the things that you can do in GitHub, but the general idea here is that there's more that you get from GitHub source control hosting than just the source control. And so it's something to just consider in your organization is if you kind of bet on using some of those features where, for example, the code security screening automatically is like, well, why wouldn't you want that? It seems like a very useful thing to include in your project. And so it's just yet one more thing that you don't have to build when you're using these third-party build servers. So I think that's another thing that's hidden here in the build servers is where are you hosting your source control? And a lot of times there's a compelling case to be made for using, an offering that's constantly getting new features, constantly doing things that help you build out your continuous integration, continuous delivery department. So this is just phase one of build server. Let me get into a little bit deeper now into build servers and also talk about more options with build servers and continuous integration. So one thing to think about as well is cloud native build server. So we talked about open source and we also talked about the third-party SaaS, but what about cloud native build servers and what does that even mean? Well, the interesting thing about the cloud native build servers is that all cloud platforms have their own build offering. So they have a competing product with GitHub Actions, competing product with Jenkins, and with AWS, they have one called Code Pipeline. And what's nice about Code Pipeline is that it also copies many of the features that you'll see with a GitHub Actions, but it's deeply integrated. We'll just call this DI for deep integration, deeply integrated into the AWS environment. So the advantage of this is that if you're doing deployment or continuous delivery, there are some really strong reasons to use something like AWS Code Pipeline. And I think we'll have time to get into some of that today. The other one would be GCP. So if you're using the Google Cloud Platform, what would you do? I think it's called Cloud Build is theirs. And I think we might have a little bit of time to get into that as well. So GCP Cloud Build, also deep integration. So if you're going to deploy a Flask application, for example, you could automatically do the deployment by hooking up a YAML file, checking into your GitHub repository, and then doing the deploy. So this is really the key advantage. And then on Azure, of course, they have their own build server. And on Azure, they have DevOps pipelines. So we'll go through here, DevOps pipelines. And in all these cases, the key point here is that my recommendation is if you're, it's almost like a conditional statement. If, on cloud, use, I think it's a no-brainer to, if you're on the AWS cloud, use their native tools. You're going to have a great continuous delivery story. If you're on GCP, use their native tools. You're going to have a great story. On Azure, same thing. Now, I will say that you potentially the best strategy would be to use both, and that's my recommendation. Is these third-party SaaS? I think they actually play a role in that they can offer really powerful, we'll just call it like dev tools. And so it's probably not a bad idea to kind of leverage those for the, we'll call it, code analytics, doing things like linting and security tests and all that kind of stuff. Like, why not just have that? That's not really what these cloud-based build servers will specialize in. And so if you do both, if you do GitHub and have your source control hosted there, plus you use some of their techniques, it doesn't preclude you from also having a separate deployment process that uses code pipeline or cloud build or DevOps. So that's what I typically find myself doing is for the analytics, because I know that these providers are constantly going to get better and better and better at doing stuff. I use that for what it's good at, and then for the actual continuous delivery aspect of it, I actually use the cloud native tools. So it's just something to think about. Now, let's keep moving down this chain here and talk about source control. So as I mentioned before, with source control, this is a really common thing to consider that isn't really deeply thought about. And one of the things to think about is that, first of all, what are the options? So we got, GitHub is one, obviously probably the most popular source control offering, but not only is there GitHub in the third-party space, but there's also Bitbucket, which is owned by a large company, Atlassian, and then there's also GitLab. And so there's several options in this third-party hosting space. And as I mentioned before, a lot of the advantages happen to be around this analytics space where you're able to get a bunch of really great feedback from your project and information. But something else to think about would be, what are the cloud native source control options? And this is also a native offering to think about, which is that you can host the source control in the cloud environment as well. So AWS has this. I think theirs is called Code Commit. GCP has this as well. They have an offering, and then Azure has this. So why would they offer this? Again, the reason they're doing this is they want to have a very narrow pathway that makes you have great integration to their particular cloud platform. So there may be some cases where you could mirror your code into one of these cloud native platforms, and it's really up to the use case that you're building in. But why would you do this? One is that you would have deep integration, which could be really helpful. Also speed. So if you're deploying your code really frequently, why not have the code commit or the source control repository be literally right in the same data center that your deployment goes in? So that could be a huge advantage. Another one that isn't talked about enough, that is a pretty big one, is there may be some cases in terms of security where you don't want to increase additional security vectors or risk vectors for your source control. So if you have extremely tight security because you're dealing with health records or something like that, then you may want to not use a third-party service because you don't want to add another tool to your ecosystem here just because you can do it. You would want to potentially have extremely high levels of security on your cloud platform of choice. So there's just some things to think about, I think, that are not necessarily fully thought through in terms of source control that correspond to testing. So now let's get into the concept of continuous integration and then continuous delivery, which is also really misunderstood in a way. So first, if we talk about continuous, we have continuous integration, and then we also have, we'll just say this is delivery. Now, a lot of times it's somewhat intuitive to people when you hear about integration, but let's be very specific about what it does is that you don't want to check in code that's broken, right? And this is really one of the things that it fixes, is that if you're working with even yourself, but ideally with a team of people, you want something that can enforce the rules, right? So this is essentially law and order for your source control, is, hey, why are you checking in this code? It doesn't even compile, or the linting doesn't work. And so that's what continuous integration does, is it stops it. The other thing that continuous integration does is, as I mentioned earlier, it could have lots of powerful analytics tools. And I think this is a really underutilized component of people doing testing. Is I think the time you spend here could be really powerful in terms of the feedback loop. And in fact, I wrote a project called DevML that is an example of my own homegrown analytics tool. It's on GitHub. I can share it later. But I go through and generate all these statistics about code, and the statistics look at things like the behavior, the human behavior of people. And that's one of the things that is really interesting in terms of looking at testing, is that because I have a data science background, I'm not just looking at the software engineering aspect of it, but I also want to look at the humans that are doing things with the code. And in particular, one of the behavioral things that is very interesting that I've seen as an engineering manager is when are people checking in code? And this is a very interesting question, because let's give an analogy here of you hire somebody to work on your house, and let's say it's a painter. And if the painter is supposed to take, let's say, 5 days to paint your house, and it turns out that there's only 1 hour per day that they're painting, what's going on? And I think that's a direct correlation to software engineering. If you're only checking in an hour's worth of work per day, why? It doesn't mean that the painter is actually messing up either. We need to dig into what's happening. So you could use something like 5 whys and dig into it. And so let's just do that let's do some kind of a 5 whys approach to the painter. Say, well, why can't you paint the house? And then you ask the painters, well, there's a truck that's blocking me from driving up the hill. And it's like, did you ask the truck to move? And then he said, yeah, we did say that, we told the truck to move, but your neighbor said we can't move the truck because he's doing some other work. Well, now you've actually got the root problem actually figured out, which is that it wasn't the painter's fault. The painter was trying to do their job. Your neighbor has blocked the path to your house, and for the last 5 days you've been paying a painter that didn't do any work. So we've kind of identified it. And the same thing would go for source control. Is that we could ask a developer, like, hey, we noticed that most projects, people check in their code, let's say, from 9 to 5, and we'll go through here. We'll just say on a 9 to 5 work schedule, let's just say like 2-3 times a day, people are checking their code. And, typically there's, I don't know, lines of code is a little bit of a murky measure, but let's just say like high level, let's say 50 lines of code 2-3 times a week. And then it turns out that suddenly that's not happening. Well, why? Well, what's happening? Well, let's ask. And if you ask the developer, hey, why is code not being checked in anymore? What's occurring? It could be that, let's say, the product manager is constantly pulling the developers into meetings, and they spend all their time talking to the product manager. Well, that is a very inefficient process. It's helpful, obviously, to have interactions with people, but what's happening is that the product manager has stopped all development work, right? So these are the kind of things that are a little subtle that are really helpful to dig into. And that's just one, that's the human behavior. But you also could look at security tools as well. So we talked about that. You could look at security vulnerabilities. Those are all super helpful. So there's a ton of things that you can do with continuous integration. So my recommendation is use the best tools that are available. Also code quality. We haven't talked about that. The other one is, we'll just say CQ for code quality, is things like, what are the times that you've actually modified a file? And I do have some of that in this package that I wrote, is why are you changing the same file every single week 4 or 5 times? And that's another good question. And we'll just go here and we'll say why. Why is that? And it turns out that maybe the project is so damaged that it's an unknowable problem, and the person that's working on the problem only has, let's say, 2-3 years experience, and they don't realize that they should just, basically delete the file, right? They're working on a file that's really problematic, and it's got 2,000 lines of code and doesn't even make sense. And so they just constantly break it, unbreak it, break it, unbreak it. And so that's actually a vector for bugs. And so that might be a situation where you go through and you say, look, this is a real problem. Let's just delete the code. Let's start over. Let's actually fix, the root of the problem. So I think that's another thing about continuous integration that's really important to think about is how do I actually use it for deep analytics and deep questioning of both the behavior of the humans and then also the actual quality of the code. So that's the integration. Now let's talk about the delivery. So this is, I think, a very misunderstood concept. But let's start with the part that's easy. So the easy part here is that, let's say you have a Flask application or web application or a command line tool. The idea is that as soon as it goes into the source control repo, that source control repo sends an event. And what happens is that that event goes to some build server, and we'll just call this the build server. And as we know, what does the build server do? It just runs stuff, right? And so in this case, it would be literally some series of steps. And in most environments, there's a templated setup where there's a branch, like let's say the development branch, there's a staging branch, and then there's a production branch. And in those particular examples, what would happen is that there would be a different environment that would correspond to each branch. And then at that point, you would deploy that code to the appropriate environment. If this is the dev branch, it would go to the dev environment. If it was the stage branch, it would go to the stage environment. So that's really the easy conceptual concept. And in fact, it's actually very powerful to have this concept of continuous delivery. But one of the issues with this is that just because you can deploy your code automatically to production, it doesn't necessarily mean you do. And so that's the core distinction between continuous deployment and continuous delivery, is that your code is always in a deliverable state. So there's nothing that you have to do to make it deliverable. So there's nothing you have to do to change this. And I think this is really misunderstood, is that when you talk about continuous delivery, like, oh, well, what would go wrong? What happens if we push changes to production and then the SQL database deletes 20,000 rows? Yeah, that's bad. In fact, that's happened to me personally. I've worked at a company where I was in charge, in fact, and someone deployed code to production and deleted 20,000 records, and we lost them permanently. So that happens. That's not a theoretical problem. What it means is that you could deploy it automatically. Now, should you is really a question that's specific based on the company that you're in and the problem that you're solving. You may want to have a human do the final, gate, right? That's one way to handle this, is that a human looks at the staging environment, looks at the results of, let's say, a load test, and then goes through and says, okay, great. Yeah, this looks good. I've done some functional tests and things are ready to go. I think that's generally not a bad strategy. Another approach is there's some more complicated, approaches where you can do things like canary-based deploys, where you can say, okay, let's just deploy a little bit of this and see what happens. If it looks good, then we'll migrate it all the way the rest of the environment. So I think that's the main thing to think about in terms of continuous delivery, is that everybody should do continuous delivery, and it's not a one-to-one mapping to continuous deployment. Yes, you have to have humans. The humans need to make critical decisions, and it's not like a panacea. And I think in general, that's one of the core, elements of life, is that there is no answer. The answer is there is no answer. There may be good suggestions, but there's no perfect answer for any problem. You have to use human judgment, no matter how sophisticated the tool is. So that's pretty much the high level of what I wanted to go talk about theoretically. And so what I'm going to do next is I'm going to actually get hands-on here and get into some code. And what we're going to do is set up a continuous integration on all three cloud platforms, major cloud platforms. So CI on three clouds. And the idea here is that we can pretty quickly set up, let's say, GitHub Actions. And we can scaffold out a project. And then that project can be run on AWS Cloud9, which is their cloud-based development environment. Also GCP on their Cloud Shell, and then Azure Cloud Shell. And one of the reasons I like showing this particular example is that, in particular, with this kind of SaaS-based world, that notice that the code never touches my laptop. In fact, in this approach, you could have a Chromebook, and a Chromebook would work just fine. And I think this is really important to point out, is that really I have some serious doubts that if you're a cloud developer, that you really even should care about your local development environment. I mean, for an extremely advanced user, there are some advantages to it, but in many cases, I think that we'll call this the golden path, is to don't put anything on your laptop, because the laptop has all kinds of security holes that could be introduced. API keys could get checked in somewhere. You have to worry about the environment. And then just in terms of the speed as well, the speed is incredibly different. And also the capabilities, right, that you're going to get by using these cloud native environments that are deeply integrated into particularly what they do. So that's what we're going to build next. So let's get into that. And the first thing that I will do is go to GitHub here and create a new repo. So let's go ahead and do that. And we'll call this, let's go to repositories and create a new multi-cloud. So we'll call this multi-cloud, and put a description in here. This is a multi-cloud project for Python. And I will say public, and I'll just show you some of the things I typically do. I think it is a good idea to add a README. I would also add a gitignore file here. And in this case, we'll do gitignore for Python. And then I'll say create repository. Now note as well that Azure Pipelines and Google Cloud Build are options, right? And I think we'll have time to get into that, but I also could use those services to deploy the code. But right now we're going to focus on continuous integration. Okay, great. I've got this set up here. Now, what I would do next is go to first one cloud, and we'll say the golden path of the golden path would be AWS. It's probably the easiest to start with. So first up, what I will do is go to Cloud9 here and open up a new Cloud9 instance. And I'll just show you real quick. I can say create environment, and we'll say, new. Actually, we'll just call this multi-cloud, and description. This is for developing CI for Python for multi-cloud. There we go. Perfect. And then from here, I have the ability to choose different instances. Really, you just need a free tier instance. You don't need to mess around with anything. I can leave everything default, like Amazon Linux. It'll auto timeout. That's what my recommendation would be. Okay, so once we set this up, it'll take maybe like 30 seconds or something to spin this up. And what I'll do is first set up some basic scaffolding in this project. And I can actually write this out in terms of this repo. In fact, I'll also share this so other people can get access to it when I'm actually building this. Okay. So what we'll do here is we'll just build this up step by step. So first step is we have, we'll have AWS. So we'll set up GitHub repo, then we'll create a virtual environment, copy SSH keys to GitHub, and then set up scaffolding. Right, that's really the core set of steps here that we'll do initially. So let's go back here and do that. So it looks like our environment's spun up here. Now the advantage here, if you're not familiar with the Cloud9 environment, is that really it's got everything you need to talk to, let's say, S3, and I wanted to AWS S3 LS, want to list the buckets I have, or want to copy data, or if I want to, for example, upload data. If I go here, I say upload local files, I can upload things, download things. It's a really incredible environment for interacting with AWS. And I would recommend anybody that uses AWS have some Cloud9 integrated. So the other thing it has is a modern version of Python. This one's got Python 3.6, which is good enough. And what we can do, as I mentioned before, is spin up a new environment, virtual environment. So I'll say Python 3-im venv, and then I'll just call this multi-cloud. I like to name it a similar name or the same name as a repository, so I don't have to think too hard about what I called it. And notice here how I do tilde dot. All that does is take it out of my current working directory and put it into a home directory under an invisible folder, right? So dot, so just so it's out of my way. Next up, I say source tilde/dot multi-cloud, then activate like that. Now that I've got this set up, what I can do is kind of start to go to the next step here. And if I say which Python, you can see this Python is in this particular directory. So I've protected myself. That's really the first step, and I can play around with stuff. Now what I'll do is I'll try to check out this repo, and if I go to multi-cloud here, and I go to SSH section, and I say clone, this will give us a new repo, but it's denied. So why is it denied? Because I've never told this new environment about SSH keys. It's pretty easy to set up, very, very quickly here. So what I'll do is set that up next. I'll say SSH keygen -t RSA, and I'll just go through here and create these SSH keys. And from here, I'll just quickly paste these in. One thing that's key to point out here is this is a one-time only operation. You never have to do this again. It's just the first time you created a new environment, but it's worth saying because it's such a common problem for so many people. So I'm going to go here, new SSH keys, and we'll call this multi-cloud. Okay, paste this in. Once I do this, it'll ask for my password, and we're all set. Now if I go back here and I do up arrow and I go to git clone, things work. Okay, so we got two things done, Python environment. We also have the repo, so I can cd into here. Now this is the section where I would start to build out this scaffolding for a project. And in my experience, I like to create basically 3 or 4 things on every project. And I start with using a touch file or touching a file. So I say, touch makefile. In this case, this will be the thing that's going to hold all the instructions for my project. And you may be asking yourself, like, wait a second, what is a makefile? Why do I want to use it? The core idea behind a makefile is that there are many really tedious commands that you have to type in, like installing software, testing my software, that involve lots of flags on a command line. And it really is just irritating to have to remember what those are. And it's a lot better to abstract it and say make install or make test or make lint. And so really it's just a simplification of what normal people are doing, and it puts those recipes into one section. So if I go here and I look at this makefile, what are the sections of this makefile that I will need? So you would need actually, before we do this, make sure that you always change to tabs. Make files like tabs, not spaces. So once I do this, I would do several sections. I would have an install, a lint, and a test. I've already got one of these created earlier, so I'm going to go to PyTest here, and I'm going to just copy a make file that I had earlier here, and just basically use this as an example. So in this particular example here, I will have an installation section. And as I mentioned before, this is something that's nice to automate. Is why type all that in every single time you work on the project? It's just irritating. Instead, you put it into this make install section and it handles it for you. Likewise, if I wanted to format my code, I could go through here and do, automatically format it. Or if I want to lint my code, I can go through here and lint my code. Or if I want to test my code, I can go through here and test my code. So again, that's the first thing that I would typically do is put that in there. Okay, so we've got that saved. And now that we've got those sections, the next thing that we can do is go through and put the things that it's calling into this project. So I'm also going to say touch requirements. And to start with, in this particular project, I think we only need a few files. So we need pylint, we need pytest, we probably need pytest coverage, and then we also need, let's say, click would probably be a good tool. So we've got a few different libraries that we play around with, and optionally we also could install, let's say, some other formatting tool. But for now, let's just keep it simple, and we'll stay with these. Now what I can do is I can say make install, and that's really the advantage. Is that what it's going to do is it's going to run this command. And there's another reason this is helpful, is that when I later set up the continuous integration, I also can make it really simple and straightforward, because I can tell the continuous integration steps to actually do make install. So really, this solves multiple problems by using a makefile. I think this is one of the most underutilized tools that I see in working with students, is that they don't use something like a makefile. And I think the makefile is good enough. Sure, there may be more exotic tools, but make is installed on every single system that's a Linux system, or if it isn't, it's easily installable, and it just makes really a default pathway very, very easy to use. So we go through here and we say make install. All right, so that looks like it works. And now that I've got make install set up, it's pretty easy to start to build out more of a scaffolding. And so one of the things I would do next is make a hello file, just to kind of get the wheels turning here. So if I say touch hello.py, what we will do is put in some kind of a hello world script. And let's just make something simple here and say, hello, and maybe I can have it take, a name or something, and we can say, print my name is, and we'll do f strings formatting here. Actually, we'll do my name is, I'm going to use Python 3.5 formatting, so I'll just say %s %, and then we'll say name. And the reason why is that the Azure environment only supports Python 3.5, which is kind of irritating. And then we'll just say hello, and we'll say hello, my name is, and then we'll go through here and say hello, Bob. There we go. So if I run this, we can say Python hello, my name's Bob. And if I want to later turn that into command line tool, it's pretty easy. But something like this is a good place to start the scaffolding. Now let's look at the makefile and see what other things that we can hook up here. Well, we could hook up the this pylint as well, right? So in fact, it should already work. So if I type in make lint, this will run pylint. And notice a couple options here and what they mean. This first option, which is disable, I think it's recommended in configuration warnings. These, in my opinion, are kind of a nuisance and don't really add much value. So I always disable them. And then later, if I wanted to disable a specific error, which I think we will get into with something like click, where there's something that the framework itself is so fancy, it doesn't know how to, like pylint doesn't know how to process it, you can disable specific warnings. But in general, I think that this --disable equals RC is a really good kind of default config. And I'll show you why you would use this, is that it can catch syntax errors very easily. So for example, if I just go through here, this is a bad code, right? It even tells us in unknown syntax. If I go through here and I say make lint, boom, it immediately catches it, tells us the line of code that there's a problem with, and in addition, shows me that it's actually character 5. So really, really powerful tool that I would recommend on every single project to use pylint. So now that we've got this, really we're ready to essentially cook this code up and push it into GitHub. So that would be the next step. So in order to do that, I can type in git status, and you'll see these core components. Really, this is the core of the scaffolding. We've got a make file, we've got a hello file, and we've got a requirements file. So let's go ahead and check those in. So we'll say git add make file, git add hello, git add requirements, and if I commit those in, we'll say adding scaffold. Okay, now it'll give you these warnings, which are a little irritating initially. You could either create a configuration file first that will solve this, or I feel like it's not horrible to just type in my information. And the reason why you would do this, and it is recommended to do this, it's optional, but it's so that you have information about who's committing things to your repository, which is really important. So if you wanted to do analytics, for example, this would be a great way to get that done. So we go through here and we check in this, and I go through and I write the file out, and then I exit, and then I can push this, and this should appear inside of this repo. So if we refresh here, you can go through here and see that everything's inside of here. So next up here, I think a really good step would be, well, we've got linting set up. What about testing? And so I would include linting as a part of testing, but let's actually get some testing set up here as well. And so for that, it's fortunately pretty straightforward. What we can do is just make a file called test hello. So test_hello.py, and PyTest in particular makes it incredibly simple to test code. And so I'm actually going to change this function a little bit to make it more like test friendly. So what I can do is actually say, let's just do this. We'll just say return, and we'll put in maybe a string, this string here. Let's just take this string out. There we go. We'll return the string, and then we'll, instead of doing hello like that, we'll do print hello. We'll do print. We'll do hello, but we'll print hello. There we go. That way, I can actually assert some things on this code. Just double check here that it works. So if I just type in make lint, that's one way to, you don't have to run the code. Just, okay, it looks like it works. So if I go to this test file here, what I would do is I would say from hello import, did I say hello? That's funny. Yeah, hello, from hello import hello, which is also like, maybe I can actually change that. We'll call it speak, just to make it a little bit less convoluted and confusing. We'll go through here and we'll say speak. There we go. And then from here, it's pretty straightforward. I just do def test speak, and I just assert something, right? So I can say assert that, the word Bob in speak Bob, right? So it does that word appear in the output. And so we can test this really quick, and it should. And if I say make test, it passes. And in fact, we have 100% test coverage. Now, if I put in, Janice in here, let's see what happens. No, right? We see that that's actually, it's not working. But that's the core. That's essentially the core concept, is that we're validating that the code works. So I can also check this in, right? So I can say get status and get this in here. Hello, git add test, same thing, committed, say adding my test now. And then we can push this into our project. So what's nice about this is I've got a pretty good, local setup, but what we haven't done yet is enforce quality on the build server. And so we should do that first before I get into other clouds. And so in order to do that, what I'll need to do is go back to my project, refresh, make sure that those changes are there, and actually go to something called GitHub Actions. As I mentioned before, this is a deep integration to GitHub, and it can run our code, lint our code, test our code, do all kinds of awesome things for us. So I'm going to click on GitHub Actions here, and then I'm going to say set up a workflow yourself. GitHub Actions can do tons of different things. We're going to make it really simple, which is we're going to just tell it to do the things that I was doing locally. I'm going to tell it to make a lint, and I'm going to tell it to make a test. That's it. So in order to do that, again, I'll just be lazy and just copy one I've done earlier and grab a GitHub workflow. Here we go. This looks pretty good. And actually the name can be anything we want as well. So in this case, it's main.yaml, but I'll just put this in here. And let's look at the steps here. So we can call this a particular job. We can say this is a Python application test with GitHub Actions. And when will it be run? It'll be run every time I push the code, this will run. Now, where will it run? It will run on Ubuntu latest. So that this could be a place where you could decide a different operating system. Sure, this works fine for us though, Ubuntu. And then set up Python 3.8. Sure, we can use Python 3.8, even though we're in Python 3.6. That's fine to use Python 3.8. We could also change it if we wanted to. And then let's go. The first thing that's going to happen is install dependencies. Why would we want to do this? Why would we want to install our code every single time we do a push? One reason is that you can instantly tell if a package is broken, which happens all the time. And this hidden dependency, that if you're not checking it constantly, you're going to get burned by it. And so this is really important to do this on your project, is to install it. And fortunately, because we have the makefile, imagine if you did a bunch of work locally to get installation working or testing working or linting working, and you have these giant complex commands that are piped together, and then you got to do it again in this. That's the reason to use a makefile, is you do it once, right? So it eliminates this, copy pasta, right? Where you're just copying and pasting code everywhere. Just do make install. It's much simpler. Now, this is a formatting step that we'll take out for now. We might have time to get into that, but I'm going to lint my code again. Just make lint, and then I'm going to do a make test. So this is going to add a tremendous amount of quality to my project. So we'll say creating initial CI pipeline. And then I can commit it, and immediately it will go through and it will run this code, and I can select it by going to GitHub Actions here, and we can just watch this thing go. Okay, once this thing is running, I even can look at the output as well. So that's one thing that's really powerful about this, is that I can check it out, look at what's happening. The builds, and what'll happen is once these are run, that it will show me each step as it's actually going through. So we can see here that this got passed, all of these steps we're able to pass. So we're able to successfully build our project. And if I want to as well, what I can do is under this section here, say create status badge, I can copy this and then put this into the repo. So fairly straightforward process that gives us a really powerful continuous integration tool with minimal effort. That's really the main advantage of this project. And then every time great. Okay, so we're back to the sketchpad here, and what I'm going to do is just talk about functional testing and really the ideas behind it. And in fact, some of the things that I've experienced in my career with functional testing, a lot of times the stuff that we covered was really more kind of diagnostic, right? Linting, unit tests are fairly diagnostic, but there's also a strong need for functional testing. Like, basically why would you do functional testing? And one really critical reason in particular, it would be something like load testing. And this is something that is actually a really big problem that can be addressed by writing a specific type of functional test, a load test. And the way I've done this previously, in fact, this was maybe over 10 years ago, I was working at a major film studio. So let's just talk about this as a case study. I was working at a major film studio, and it was actually funded by Disney, really large, hundreds of millions of dollars budget. And there was huge outages. There was, in fact, a critical deadline. So we'll say the problem was outages due to performance of the centralized database. And then also there was a crazy deadline. It was a Christmas movie, and actually it was summer. So we were in big trouble. And this all happened. I can say I wasn't a part of the original architecture. And so one of the things that the team, including me, did is we went through and first got the code into source control. So believe it or not, the code was not checked into source control, which is the kind of stuff that they used to do in film. Second, we went through and started to set up, linting, which I just showed you. We set up some testing, but that's not enough to address the core problem, which is the outages, right? There's a massive performance problem. So what we had to do was set up a staging environment. And this staging environment was basically an exact replica of what the production environment was. And this is critical because now what we could do is every time we made changes to the code, we could kick off a job that actually did several different performance tests. So, in this case, the core functionality, I think I even remember this from scratch, was it was an asset management system. Is can I check in an asset, right? That was one. Another one was, can I copy an asset? Like basically, these are business operations. And then what we would do is see at the very end of this load test, we would put it onto a dashboard. And this dashboard would essentially tell us what the capability was of the system. And it's essentially a scoreboard. So the scoreboard would tell us, hey, your system can it used to accept 50 users requests simultaneously, now it can accept 70, right? And then we could look as well at the monitoring of the database. So we could look at the CPU, we could look at the memory, we could look at disk I/O. We could look at all these characteristics and tie them together. So that's one of the key reasons to do automated load testing, is that if you don't, you're going to have performance problems at some point, and you're going to be very frustrated because you could have done something that's fairly straightforward and prevents problems and then eventually you'll have to do it. And so what we eventually did was have this feedback loop where we were constantly testing things, and I would say we found it wasn't a straight path. It wasn't, it was a windy path. Basically, we had, let's say, 100 significant problems, at least 100 plus significant problems, and we had to just keep fixing them. And then we thought we were done, and then there's another 20 problems that crop up. So I think that's really the core idea, is it's a way of testing your code automatically for in terms of a specific thing that it does. And in fact, unfortunately, I've seen the same problem occur in other industries as well. So for example, in the game industry, this is a really critical problem that I've worked in the game industry as well. And they are also surprisingly notorious at delivering software that doesn't work, just because of the nature of the industry. And so, for example, what's the doomsday scenario is that you spend 1 to 2 years on a project, which I've been on those projects where they put me in to fix it, and then nothing works. And a lot of the reason why nothing works is that they're not doing functional testing, and especially they're not doing load testing. So I think these are two related. They're very highly related. Is that a functional test could be, do the core actions of my application, but then do them at scale. And if you're not doing this automatically, it's easy to get burned. And it really is, I would say, a best practice for any professional company to have some form of automated load testing. And since we talked about with continuous delivery, right, this is also ties into the point of continuous delivery, which is that if you can always deploy to a staging environment and always run a load test, why would you not do this? It's an automated process that gives you safety, lets you see what the bugs are, what are the performance bottlenecks, and it's just a good thing to do. And so some of the tools as well, let's just talk about that real quick, that are available to do load testing in the Python ecosystem. Here's just two that I've done previously. So for load testing, I think some good tools to think about would be Locus. So Locus is a pretty good tool that can actually do load testing, and you can write really simple Python-based tests for a web application. Another one that I've used that's a service is called Loader.io. And what's nice about that is you could give it a URL, like a route, like game or something, and then it can programmatically, you can just call it on a build, and then it'll spin up, let's say, a bunch of, requests until finally the server flatlines, and then you can basically see at the very end, it can accept 500 requests per second or something like that. And then there's other tools that are more advanced as well, that can do things like this. But I've also used a tool called Appium to do mobile testing and functional testing. And so this whole space, though, is a great space. This would be for mobile, is that you can with Jenkins, for example, you could go through and set up an Appium thing that would go through and click the buttons in your application and then run tons of simultaneous jobs and do a load test directly in Jenkins as well. So these are just a few that I've used. And what I've basically discovered as an engineering manager is that this is one of the most powerful techniques you can bring into a company if they're not doing it, and instantly make progress and get a great reputation, because it's going to find a lot of bugs in your code. It's going to give you things that you can fix, and also it's going to ensure that you can deliver features really rapidly. A lot of companies in particular with mobile, if it's a game or if it's a software as a service company, that's the critical component that they're building, and they will want very fast delivery of their mobile app. Maybe they want to deliver a mobile update every 2 weeks, for example. These are all things that are really important that can be done if you have load testing and functional testing done automatically. So that's kind of the theory behind it and why it's so important. So let's keep going down building our code, though, and get into a little bit more detail. So we stopped at the README file that is able to do linting and testing, which is great, and we also have a passing badge here. But now let's start to integrate the two other cloud environments. So the two other cloud environments, one would be this Azure environment. So I'll make this a little bit bigger here. So I'm going to go to Azure and click this icon that says Cloud Shell. And what's neat about Azure is that it really is similar to Cloud9. It's just a terminal that's running a container that has all the Azure stuff inside of it. And so I can really easily get that project checked out and start working on it. So the first thing I would do again with here was just kind of check what version of Python. We can see it's Python 3.5, which is a little bit irritating because it means there's certain things I can't use. But for here, I'll say, Python 3-m virtual environment, and we'll call this multi-cloud. Right, so I'll create my virtual environment. Next, what I'll do is I will source this virtual environment, and then I can check out my repo. Now, I've already created SSH keys in this environment, so I shouldn't need to do it again. So I'll go to multi-cloud here and go to my project and go to the code view and copy this URL. And then I can say git clone, and this will let me clone things here. Now that I've cloned it, I'm going to cd into this. And it should be really easy to get this whole project working because of all that hard work with the scaffolding and the build server. It's trivial. In fact, we can look at this project, and let's just double check this makefile that we have install, lint, and test. So all I need to do is just say make install, and that'll install it. The next thing I'll do is make lint. Does our code work? It does. And then do make test. So this shows the power of why you want a build server. Is it makes the installation of your project trivial. And a couple things to point out here in this Cloud Shell environment is that if I click on this icon here, this will allow me to open up an editor, and I have those same type of capabilities that I would have on the other environment that I was using in Cloud9. So if I go to multi-cloud here, if I wanted to add something to here, it would be pretty easy. It's a really good and rich environment for me to work in. So, and in fact, I can just basically have a split window if I wanted to. So from here, what I'll do next is maybe go through and make a small change and push it to see if I can test the way things work. So what I'll do is I will comment out this code and make a bug and just double check that our build server catches this bug. So what I can do here is say make lint. This should fail. Good. So I'm going to check in intentionally broken code. So we'll go git status, git add hello, and testing build from Azure. Great, that looks like that is working. And then from here, I can actually go through and go back to my GitHub Actions and double check that everything is working. And in fact, we do have things working. Okay, it sets up, it works. This should fail at this step right here, and it won't even get to the test step. It should fail right at the lint step, which is pretty nice because it verifies, it lets me know where the error occurs. Like if it's a lint error, it's syntactic, but if it's a test error, it could be business logic, right? So we have a syntactic error here, and so we can fix it really briefly. Again, I just go back here, go to my editor, save it, say again, git add, commit, push, and this will fix it. So now that I've got that set up, probably the next one to, this will fix it here, the next one to set up would be to go to GCP. And so I'll go to the GCP account next. I'll just go through here and say GCP console and set that one up. And all I need to do is select again the Cloud Shell. Notice that these cloud vendors are not necessarily the most creative folks. They're often just kind of looking over their shoulder. Hey, what'd they do? Oh, let me do that. What'd they do? So a lot of the same tech. The good news is that if you know one of the clouds, it's very likely that many of the same ideas will work on the other cloud. And so that's just something to be aware of. Okay, it looks like it's set up. Now, this environment here is, again, very similar. I'm going to deactivate a virtual environment I have set up here, make this a little bit bigger. And to start with, again, I have Python here. That's Python 2, but I would want to use Python 3 to interact with this. So we go Python 3, Python 3.7.3. And I believe by default, it doesn't install virtual environment into Python. And you have to use this technique, virtual environment. So we'll use this. And I'll say virtual environment / multi-cloud. There we go. And that looks like it works. So I'll type in source / multi-cloud bin activate. There we go. Now that I've got that set up, what I can do is check out this repo. So again, I'll go back to my project here, which we can see it passed that last test, and then check it out. Go through here and check it out. So git clone. There we go. So now that I've got this set out, I can go into multi-cloud, and then again, the same thing should occur. The same thing should occur, which is I can say make install. And this will install all the packages into the virtual environment that I just set up. And then we can do a make lint. Here we go. Here's a make lint. And I also can do a make test. Right, so everything's working here. It also has the same capabilities as well, and they're very similar. It's almost like Google and Azure are copying each other. If you click on this, it's almost the identical type of experience, is that it opens up a cloud editor and you can go in here and start editing your code. So if I go to that project and I go to multi-cloud, I can again type in hello right in if I wanted to add something like print, this is fun. There you go. I added a little bit more there, and then I can go through here and go back to the terminal and then say Python hello, and we go. We have some changes, and then do the same thing that I did with Azure. Get status, add hello, adding GCP content. So now that we got some great capabilities set up where we can work on any cloud, and we've really gone through and shown why scaffolding is so important and build servers are so important. I think the next step would be that I'm going to go in here and start to make something a little more interesting than just this simple hello tool. I'm going to build a command line tool, and then I'm going to test that command line tool with functional testing to invoke the parameters. And that's really more of a useful type of a skill, and I would say a skill that everybody should have, especially if you're doing with cloud, data engineering, machine learning engineering, is can you write a command line tool in Python and then invoke it programmatically so you can test the functionality. This is a critical component of mastering those different job titles. So what I'm going to do here next is I'm going to basically clean this up a little bit, and I'm going to basically make this a command line tool. So let's go here and let's say import click. And in fact, I might even go copy a command line tool I've created recently, which is, let's see, what have I gotten here? Click. Yeah, this looks good. Let's just use this as a scaffolding here, and I'll just tweak this a little bit. So I'm gonna do this. So I'm gonna paste in this code here, which will be a good template. We can see we've got click installed, and the reason why I like using click as a framework for building command line tools is that it maps a function to a command. And I think that's a really powerful pattern because it's the same way Flask works. And so what you do is you type in @click.command, and that turns it into a command line tool. And then all you really need to do is match up the name here with the parameter, the flag that you're pasting in. And in this case, we've got a function called Marco. And so this Marco function says if the name that is passed in says Marco, then echo out Polo, otherwise echo out no match. And at the very bottom, so really this is very easy to understand. The only part that might be a little bit tricky are these three lines. So all scripts in Python have to have this line. It's just boilerplate code, just to put that in there. And then you would need to invoke the name of the function inside of your command line tool. So this would be Marco. And then this line tells Pylint, hey, look, this tool is too fancy for you to understand everything it's doing. So this particular thing, disable equals no value for parameter, it just tells Pylint, don't throw a warning. And so now that I've got that set up, I can test it out and see what it does. So I'll type in, I'll save this first and do Python hello, and it says no match because I didn't put anything in. So if I go -- help, it will show hello here, and it'll give me the flag -- name and then -- help. So I'm going to go through and follow what it says. I'm going to say -- name here, and I'm going to put in the word Marco. I don't think I need to put quotes here as well. And there we go. It returns back Polo. So it's working correctly, but if I put in Bob, it says no match. So we've already got enough action to potentially build out a unit test here for this, or a functional test for this command line tool. So what I'm going to do is I'm going to have to change this, because if I type in make test, it actually blows up, right? It says, uh-oh, there's all kinds of problems here. Nothing works because I totally changed the code. So what I'm going to need to do is go back to this test hello, and I'm going to say, in fact, change it so that it's more PyTest friendly. And so I could actually write two forms of tests if I wanted to. And that's one approach to testing this. So let's actually reformat this code a little bit. What I could do is actually pull out the logic inside of here and actually make another function that is more the business logic. And that could be the unit test. And then I could have a functional test that tests the invocation of the command line tool. And that, I think, is an interesting approach, especially if you're building a larger project. So from here, what we can do is we'll just call this logic. And what it will do is it'll take a name, and then it will do the same thing that this is doing earlier, but I'll just tweak it a little bit. So I'll say, if the name is Marco, we'll just tell it to return instead of echo it out. So we'll return Polo. And then in this case, we'll also say return no match. So what's neat about this is that I can essentially build out a unit test that tests the actual logic. So the reason why this is a really powerful pattern is that this could be the way you develop code. In fact, maybe you have a module that has a whole bunch of stuff that you've developed as a library, and then you want to invoke it in a command line tool. Well, just build this out and pull in just the pieces you want into the command line tool and have the command line tool orchestrate it. So what I'm going to do now is I'm going to go back here. I'm going to say test logic, And what we're going to do is, in fact, assert a couple things. So we'll say, for one, that this, we'll say from hello import logic. And we will do this. We'll say assert that Marco is in the output of when I actually pass in assert Polo is the output when I type in Marco. And now if I run this, this should show me that my test coverage, it should pass, but there's missing test coverage. Now, why would the code be missing test coverage? Well, it's missing test coverage because of the fact that I actually don't check this, and I also haven't checked this part of the code, which is the logic that orchestrates things. So in order to do that, I need to change my command line tool to have a second assertion, and I'll say assert that no match is equal to logic Bob, right? So basically, when I call this with the other statement, it should also not work. And so this will I should increase my code coverage by a couple lines. Let's double check here. There we go. So we got a little bit better code coverage here. So that's great. So now what I'm going to do is I now can move on. So we know that the logic is pretty good and it's tested, but now let's actually tweak our command line tool here and make it actually use this logic function. So I'm going to change this thing now. Well, I guess Marco is good enough. It will keep this the same name, but what we'll do is, in fact, this now becomes much simpler code, which is pretty neat as well. So I can go through here and add some help documentation. Say this is a Marco Polo function, and then I can just basically call this, and I can say, result is equal to Marco name, right? And then I can just basically say, there's no if statements. There's just one thing, basically, which is that inside of here, I just echo out the result. So that's another thing that's pretty cool about this, is that I can actually just dramatically simplify this code by, is that 4? Yeah, I can dramatically simplify this code by actually using the logic, which is separately tested, and then this function, the functionality, I can make a test for as well to just verify that things work. And so if I go through here and I do make test again, we actually have slightly higher test coverage because I got rid of some code, but now I need to actually test this out using a functional test. And so let's go ahead and build that. So we'll say def test functional, and what we can do in here is we can actually use some powerful tools that are built into Click. And so Click has a really good test runner for invoking command line tools, and you can see here it is. I can say, in fact, I'm just going to copy this because it's probably close to what I want. I'm going to say paste this in here and just grab the pieces that I need. So I'm going to go here and say, okay, I want this. That's good. I think, in fact, we want both of those. So we want to import that second function, which is the test, the command line tools logic. And so, in fact, test Marco, what I'll do is I'll say, so we can get rid of this one. It would be invoke a click runner, invoke it with the name Marco, and assert that the exit code is 0, so that it worked correctly, plus make sure that the word polo is actually in the output. So this tests one of the conditions that you would actually come across. And so we could say test Marco polo, and let's go ahead and run this out. So let's go through and say make test. And in fact, we've got an assertion error, and it says 2 is not equal to 1. And that might be because, what are we doing here? If name is Marco. From runner invoke Marco. Dash name is Marco. Interesting. I'm not sure actually why this is failing me right now. It's giving me a warning, but we can from hello import Marco. Runner invoke Marco. Let's just double check that I've got this. That looks correct. That's logic. Oh, you know what the problem is it did catch a bug. So that's the great thing about a functional test is I accidentally showed you exactly why you would want a functional test, is that I had the wrong name of the function in here. So it failed. So what I need to do is change this to logic. So even as good as you think you can build something, it's really easy to catch a mistake that is subtle like this. And so if I go through here and I say make test, there we go. We got 91%. So now the question is, even though I've got this great command line tool, what can I do to get 100% test coverage? I don't really worry that much about 100% test coverage personally, but for the sake of treating this as an academic exercise, let's go full speed. It's probably because we're also maybe not testing, no, actually, I think we do actually catch that. We actually do catch that that option by doing this. But if we wanted to, we could add another test case here, and we could actually test the negative of Marco, so that other condition. So if we go back here, we could just build another one. We could just copy this and say test Marco Polo, Marco Bob. We'll test Marco Bob, and Marco Bob would pass in the word Bob, and then we should get back still an execode 0, but in fact the word no match should show up. So if we run this, I don't think it'll change the percentage of coverage. It doesn't, but we've actually added a little more safety. So that's another reason why the coverage, there's no silver bullet. Personally, I think it is important to check both edge cases if I really, really cared about this command line tool, even though the logic itself essentially tests it. Why not? Why not have a little bit of extra, coverage there in case in the future somebody broke it? So I think it's 90% is good enough. And so from here, what we can do is actually just check that make lint works, and then go through and check this in. So we'll say get status, and I'll say get add hello, get add test hello, and then commit this. So adding test code. There we go. So we've got a pretty good command line tool here that in fact, if I go back here, I don't think I have anything fancy that we should be able to test on any of these other cloud environments. So if I go to Azure, I can go through and say get pull right here, and then I can easily do basically Python hello and just tap to do name and do Marco, and everything works. And if I pass in Bob, or Sally, or Jim, whatever, it doesn't work. Like we have a pretty good format. And also the same goes for GCP. Same thing. I can just do get pull, and the same code is cross-platform. I can just type in Python hello right here, no match, do name, and do Marco. Marco works, and do Bob. Bob doesn't work. So great kind of test of why functional testing is really so powerful, and how it can instantly add value, especially if you're working in multiple environments or even just one environment. So the next thing I think that would be good to do on this is to maybe extend a little bit some of the functionality that you can do with click here. So one thing that we could do that I think is an interesting approach is that you can actually add some colored output to click. And so one of the things that I like to do is add basically I think it's click.style. You can say, and we'll add an F string now so that I can show you one of the things that we're going to test for, and we'll say, I believe you can say the. Let me look at the style here. I have it in another project, or I can just do click.style. We'll just look at the colored output. Say color. Let's see here. Style, color. Where's your color example? Here we go. So we just do something like this. I'll just copy this and just take some of this. So we'll go back to here and put in, it's going to be something like this. So we'll say the foreground here will be like, foreground will be green at first. And we'll say checking Marco Polo. All right, that looks good. And then for the result, we can do maybe even make it a little bit fancier and say, if result is equal to Marco, we can actually add a little more fancy stuff here. What we can do is we can do click.echo, and we can do results, and we can make the background blue and then the foreground red. So let's do this. So go here. And that looks good, right? And then we'll make the foreground red. And then if it otherwise, we can do maybe a blinking one. So we can say here, and we're going to do this, and we'll say warning, or let's leave attention. Let's be lazy. We'll say attention, and then we can go through here and put the other result. Wrong name. Attention. Wrong name, like this, and then we can put in this result here. There we go. So we've got this. Maybe I'll just put this on the next line to make it a little bit cleaner. There we go. That looks good. And I think this is going to be pretty helpful. Let's double check that I didn't make any bugs, which is very likely I did. So that's got, I think I need to close that. That might be the error. Yeah, there we go. So this looks pretty good. So it'll depending on what gets passed in here, it will print different colors to the output, which will expose some problems. Now the other thing I'm going to do is if I go to the make file, notice I have this make format, is I'm going to also do make format, which is it's not installed, so I'll need to go through here and do an installation. So I'll go through here and I'll say Python black, and I'll do make install. And then this will allow me to upgrade my code, upgrade the formatting of the code. Now this is weird in that it says, well, that's the least important thing I want to do is format my code. So what we'll do is we'll just remove that for now. And I don't know why that tool has got problems. Don't care. So what I'll do then is just is try out the tool. So we'll say, hello. Look, by default it says checking Marco Polo. It says attention, wrong match. Now it's not blinking though. So let's maybe see if we can fix that. Why is it not blinking? That's weird. Seems like it should blink, but it doesn't seem like it's blinking. Oh well, it would have been fun to have it blink, but it doesn't blink. Maybe this terminal doesn't support it. But now let's pass in a name is equal to Marco, and in this case we somehow screwed it up. So if the result is Polo, that's why we have a logic bug here. If the result is Polo, then do this. Okay, so let's go through and we'll print this out. There we go. So we say checking Marco Polo, boom, it does this syntax. So you can see how you can extend, once you start to get this powerful, breakup here where you have the logic in one section and then you have the command line tool invocation. They're in a way two totally separate things, and we can actually build more complex and powerful command line tools. So from here I can actually do a get status and see that I modified the make file. So I took out that formatting, whatever, it's the tool has got a problem, let's not run it. And then also I have the changes to hello. So I can next here commit this. So we'll go add make file, get add hello, and commit this code, adding new functionality. And oh, by the way, if I do a make test here, we should see that it's still got great test coverage. So now that I've committed that, I can say git push. Okay, perfect. We've got this thing pushed. And if I go to this environment next, what I can do is click on this, adding new functionality, and go to a build server and look at what it's doing. And in this case, it's going through, it's installing the dependencies first. And then and by the way, this is a question that someone asked earlier, is that, here's the lint, we know that works, but if you want to look at the test coverage, right, you can see it goes through, it tells you all the tests, and then in fact the test coverage report shows up right here, right? We can see the test coverage. And it's been able to be passed. So we've actually got a lot of functionality built into our tool, and we've got it tested with functional testing. And I also can do the same thing. I can go back to Azure and I can do a get pull. Now there's going to be a little hidden Easter egg in here that will be exposed, and what it's going to do is we'll see it right now. So if I do make test, this won't work. And the reason why I knew it wouldn't work is that this is running Python 3.5, and Python 3.5 does not support f-strings. And so this is in exactly the point of adding all these tests and things inside of your project, is that now a developer, before they work on my project, they go, oh, whoops, I'm running a different version of Python than you. What am I going to do? Like I either have to change the f strings back to printf strings, or I just will not develop on this environment, right? Or install Python 3.6. You have a few different options, but it exposes a problem immediately if that's the first thing you do is you say get pull. So if you basically do make install as well. By the way, I think I have a second problem. No, I removed black, but if you install a library that doesn't get supported on Python 3.5, that's a second problem that could occur as well. So this is really exposes how you can check bugs that would appear in your project. And finally, if we go to GCP here, if I go and I do the same thing, I say get pull, I can go through here and double check everything works, right? Marco Polo, Bob. So I guess in a nutshell, let me just wrap up really quickly with the other things that these are the other things that if you want to kind of continue on the same vein, you could look into as Locust, Loader.io. But let me just briefly summarize the at least the command line tools and why they're so important, because I think again this is a critically underutilized technique in complex projects. And so I think a really good question is why a command line tool? And the reason why you want to build a command line tool gets a little deeper, is why build software and how. And my answer to that is the answer to the command line tool, is that the reason you're building software is to, solve a problem, right? So you want to build a web scraper, or you want to build, we'll call this web scraper, or you want to build a, big data tool that, searches and finds patterns, or you want to build a machine learning application, right? So you want to solve a problem, but now gets into the how of it. Is the way you do this is you want to cut complexity in half. Cut complexity, basically from the beginning. You also want to constantly be skeptical. So you want to be skeptical of anything you're building that it probably doesn't work. Look, in my case, I had a little bug that I didn't even notice that easily I caught with a command line tool. So the idea here is that by building really small tools, you can actually accomplish extremely complex tasks. And so that's really the idea for both testing and for building complex systems. Is, in my opinion, most of the really complex things I built an entire virtual reality company's back end in about 3 months, part-time, using this approach. That was a very complex distributed system that ran computer vision algorithms, because each piece, if I broke it into 15 command line tools, then that's much different than building one monolithic application. Because with a monolithic application, which is the default, this is the standard thing that most people do, is really difficult to know if anything works. And in fact, I would say that it's really almost impossible to build a big monolithic system and really understand if it works. Instead, though, if you build all these little tools, right, that, you have one that does, maybe the ingestion of the data, you have another one that can independently scrape the data, another one that can do, exploratory data analysis, and then maybe another one that does a prediction, is that each piece doesn't care about the other piece, and that's easily testable. And I think this is the biggest secret that I could give someone, is that if you want to be 10 times more effective than anyone else, is build small command line tools that are testable, and you can build incredibly complex systems. And the default, or the average software developer, doesn't do this, and that's why problems arise in production. That's why things are slow. And I think this is really a core thing to think about, is how do I cut my complexity in half? How do I limit what I want to do? I think the default when you're working with software projects is to say, how complex can I make it? But the experienced developer will say, how simple can I make it? And how do I eliminate the risk that I'm going to fail, knowing that most projects will fail due to complexity. And so my goal is to constantly limit the complexity and constantly limit the vectors where there'll be problems, and make really small tools.